the iOS sandbox means. And I'm pretty embarrassed to say that I didn't even know what iOS sandbox is. He gave me some directions about how to start researching it, but we didn't have a lot of information at this point. But one thing he did tell me is that there is an old tool that did this decompilation, which called Sandblaster. So today I'm going to walk you through my journey from not understanding the importance of this task to completely believing why do we need to invest time in it. So my name is Yarden, I'm an iOS security researcher. I'm working at Celebrite for 7 years. I started as a decoding researcher, and for the past 3 years I work in iOS. My goal here is to provide you with information I was missing when I started with this project, and to share with you why I believe it's a must tool for all iOS securities. So we will start by understanding the iOS sandbox. We will continue with what are the benefits for us. Then we will uncover the unique file format for the iOS sandbox profiles. We will see Sandblaster usage, what its main challenge and how we managed to overcome it. And we will wrap it up with shortly review the changes done in iOS 18. So the iOS sandbox is a security mechanism implemented by Apple that actually makes our life much harder. They are well known in integrating very complex security mechanisms to enhance the protections of your system. The sandbox is designed to protect system resources such as file systems, XPC services, and system calls, and it's implemented all the way through the kernel. Sandbox profile represents a set of rules, and by understanding these sets of rules, can significantly aid identifying vulnerabilities by allowing researchers to focus on areas they are most likely to be succeed. Imagine that you're working on an exploit, developing it, testing it, just to understand that the sandbox eventually blocking you. We can eliminate this trial and error process and quickly determine if the strategy is viable or not, just by understanding the sandbox rules. Also, different processes might have different sandbox profiles, so by analyzing this sandbox profile, you can make a calculated decision. So the end goal here is to decompile the sandbox profile. What do I have? I have an all implementation of a decompilation tool called Sandblaster. As stated in the README, Sandblaster is a tool for decompiling binary Apple Sandbox profiles. Apple Sandbox profiles written in SBPL, which stands for Sandbox Profile Language, and they are compiled into an undocumented binary format. Sandblaster is a tool that reverses the binary formats profiles into their original SBPL, and it supports up to iOS 11. We are now in iOS 18. When I started working on it, it was iOS 16 and almost 17. So what is the first thing that you'll do when you need to add addition support to an existing tool? You run it. So I've continued reading Sandblaster README, and I saw that for running it, I need to extract sandbox data. Also stated in the README, sandbox profiles are extracted from the kernel sandbox extension. We have here a usage example, also taken from the README. It gets 3 arguments. One of them is the output folder, so we're okay. And we are missing the other 2 arguments. One they call SBOP, and one that they call sandbox bundle. So the profiles that I need to parse resides in the kernel sandbox extension, and they are in a binary format. They get referenced from a function called hook policy init, which is a function that initializes the profiles. If we will look at a part of this function, we can see some panic string that says failed to initialize platform profile. Now we know we're in the right location. So right above this panic string, at the top of the picture, we can see pointer points to the con section of the Sandbox extension, which points to a binary data blob. A little bit below it, we can see something that looks like a size. So now we are able to extract the Sandbox data. We have one argument that Sandblaster needs. Now we need to get the second argument, the one they call SBOps. So SBOps stands for Sandbox Operation. They are the system call that the Sandbox policy is restricting. So to find them, I just need to search one of these operations. I found this operation list. It also resides in the kernel Sandbox extension. Its file changes from version to version. So now we have all what Sandblaster needs in order to parse this profile. And actually, I really wished that Sandblaster will work out of the box, but it was far from usable because the file format has changed dramatically. It was an amazing solution up until iOS 12, and now we need to make it work to iOS 16 and above. But it's not that simple. Although Sandblaster is an amazing starting point, it needs some adjustments. But another good thing in it is that Sandblaster is doing an amazing job in parsing the complex features in this file format. So if I'll just manage to read the file structure, the entire parsing process should work. So again, the iOS Sandbox profile represents a set of rules. We have here an example. We have, if we want to run dynamic code generation, we need to have dynamic code signing entitlements. Entitlements are key value pairs that define the permission granted to a process. Without it, the Sandbox will block this action. So the goal is to get from the binary format into this readable set of rules. There are two approaches that I used in order to parse this profile. One is to compile a Sandbox of my own, and the second one is to locate the parsing process in the kernel and reverse engineering it. Each of the approaches serves a different goal. By compiling it, I can test specific scenarios, but reversing the kernel can provide me a more comprehensive understanding of the parsing process. For example, by analyzing the kernel, I discovered that there are three types of format. A platform profile, which the entire system runs under it, built-in collection, and proto-box collection. Those have different types and parsed a little bit differently. Also, I could see that the platform profile gets evaluated before the built-in collection. I've also discovered that the Sandbox is parsed and evaluated dynamically. And I saw some key functions that involved in this process, such as Sandbox evaluate that calls evaluate one operation and then eval, which they play crucial roles in evaluating and determine the actions to be taken. So let's dive into the file format. The file is structured from several sections. The header section, which have an essential information about the profile, the operations section, which represent the list we provided earlier to Sandblaster of the system call that it should restrict. They are pointing to the operation node, which are the actual rules that determine if an action allows or denied. And they are using some strings and fixed values from the literal section. If we will zoom in into the header contains type. For example, the single profile, like the platform profile, or bundles of profiles, like the collection, and a count of the operation nodes in the entire file, and operation count. We have here a small rule that I'm going to compile, and so we can see it in binary format. So it's the same example as I saw before. We have an operation which is dynamic code generation, which gets denied if we don't have the dynamic code signing entitlement. So we can see here the compiled format. The orange part is the number of operation nodes we have. You can see the operation nodes in the blue part. Each operation node is 8 bytes long, and just to tell you, we have here 3, because one is for allow, one is for deny, and one is for checking if we have this code signing entitlement. The green part is the number of operation, and the gray part is the table of operation pointers that each of them points into an operation node. I know a lot of operations, but we will make it happen. So the purple one that is marked stands for dynamic code generation. I know it because it's in the same index as it in the list we served to Sandblaster. So the purple dynamic code generation points to node 0. Node 0, operation nodes are like decision points. So for instance, node 0, if the rule in node 0 matches, go to node 2. Otherwise, go to node 1. In our case, node 2 is allowed and node 2 is denied, but it can be much more complex, and it will get going until it gets to some decision. Now let's talk a little bit about collections. Collections are essentially bundles of multiple profiles, which each profile has his own set of operation table. They are also initialized in hook policy init, and they have a different type. Let's say we have a collection profile, includes profile for process A, process B, and process C. When we decompile the collection profile, we will get a profile for process A, a profile for process B, and a profile for process C. Now, if we zoom in into the profile section, we will see that we have this operation table for each profile. This is the gray part we saw earlier, and they come one after each other. We also have here a pointer to a name, which is the name of the process that is associated with this profile. Okay, so we parse the profile, we are done with it. We are getting the decompiled sandbox in SBPL, and even though it looks readable, trust me, it's not readable at all. It's manageable when we have a really small rule, but when it gets a little more complex, it becomes impossible to read. It got into a point which this tool was pretty unusable. So then we started to think of a solution. How can we make it easier to read? So that's where my colleague came with a suggestion. These rules are only a set of if and else. So what if instead of writing it in SBPL, we will write it in C, compile it, and then decompile it with a decompiler of our choice. So we implemented it in Sandblaster, leading to this result. Each operation is a function that returns allow or deny. That way you can read basic C code and follow the rules easily. This decompiled output is way easier to read than the other one we saw before. I was happy and all, it was much easier for everyone, but then I started to get questions about how can I extract the sandbox profile from kernel. If you remember, it wasn't an easy task if you don't really know how the sandbox mechanism works. So one of Sandblaster users wrote a tool that automated this entire process, downloaded the requested kernel, extracted the sandbox from it, and ran Sandblaster on this requested sandbox. This was and is my main goal when releasing this tool and talking about it here. I wanted that the community will be able to communicate with each other, to contribute code, to improve each other's skills. But then iOS 18 was out. It was not a priority for us to parse the iOS 18 profiles, not until it got necessary. Because let's face it, it's not as exciting as finding vulnerabilities. But I'm sure you know that it's really important to invest in your tooling, so we did it anyway. Let's review in short the changes introduced in iOS 18. So another collection profile has been added, which is called Autobox. It looks like just a name changing for Autobox profile. Also the profile format changed a bit, of course, like almost every version. But the more important change is that they've added 2 more actions. So now instead of allow and deny, we have allow, deny, delegate, and Autobox. Also, in collection profiles, now each profile has a base profile. Most of them has the same base profile, which is baseline, but some of them are not. This shows how Apple constantly improving themselves, which makes us improve ourselves and hopefully collaborate with each other. There are so many things. I want to understand this mechanism. I want to understand how Sandbox extension work, Sandbox state layer, app sandboxing. I want to make Sandblaster as easy to use as possible, which is way easier when the community is helping. I will keep researching it, and I invite you to join me, play with this tool, and share the insights when you have. I personally really love this project, and I believe that there is a lot more to learn from. I would like to say thank you first to the owner of Sandblaster, also to my colleagues, Leo that implemented the C output, and Daniel Yuval that contributed to this project, and also Blacktop and IPSW, which is a great example of an amazing tool. I will publish in the next week or so Sandblaster support for iOS 18, so stay tuned. This QR code is for Sandblaster repo, and I will publish on my Twitter some resources if someone is interested in reading more. I hope you enjoyed my talk, and I have managed to give you some head start for those who want to research iOS Sandbox, and mostly to give you the information I was missing when I started with this project. There is a lot more to research and talk about, but this is all for this time. Thank you very much.